So we're going to start talking about two-dimensional motions. So things are going to be moving in the x direction and the y direction, or they're going to be moving east and south. Like in this example here. So in this one we have a boat traveling at a speed of like 8 meters per second across a river flowing at 6 meters per second. So I'm going to draw my boat here. I'm going to say it has a velocity in the x direction of 8 meters per second. It's being pushed this way with a velocity of 6 meters per second in the y direction. Okay. Now, I might get a question something like this. Let's say that I know that the distance across here is 24 meters. Okay, I might ask something like, how long will it take to get across the river? So you split it into x and y. Okay, for the x, I have the velocity is equal to 8 meters per second. It's a constant velocity. And then that the distance across is 24 meters. And I want to know the time. So I could use velocity is displacement over time. Since it's a constant speed, I don't have to worry about acceleration. And I would get 8 is 24 over t. And then the time would end up being 3 seconds. So I didn't have to worry about this y velocity here at all. Okay, I only had to worry about the x stuff to figure that problem out. Now, I could then ask this question: how far south will that end up going? So I have over here the velocity is 6 meters per second. And I can use the same time. Because time is a scalar, there's no direction involved in it, so the time for the x and the time for y are the same. So it's going to be 3 seconds, and then I want to know the change in position for it. So again, I can use the same equation, and I would get 6 is delta x is equal to 3, and then I would get it went 18 meters south. So we can treat the x and y independent of each other. Okay, the only thing that is going to be the same in both columns is going to be the time. When I'm doing x stuff, I want to make sure I'm not using any y information, and vice versa. Okay, projectile. We're going to spend most of this unit doing projectile motion. Projectile is an object that's only under the influence of gravity. Once it's fired, we're going to ignore air friction for 99.9% of this unit. And the trajectory is the path that the projectile takes. So, here's an example. If a bullet is fired from a gun and a bullet is dropped from the same height at the same time, which will hit the ground first? And it turns out they hit at the same time. Okay? The y motion only depends, in this case, on gravity. Independent of the fact that one bullet is moving in the x direction. Okay, just like up here with the boat, the x and y were independent, it's going to be the same thing here. Both objects here, okay, are being pulled down by gravity, they'll land at the same time. So the x and y motions are independent of each other. And for all cases that we do this, the y acceleration is going to be gravity minus 9.8. We're going to use minus 10 for that. And gravity does not pull in the x direction at all. So as long as we ignore air friction, there's nothing pushing or pulling it in a horizontal direction. So we can say that its acceleration is 0. And here are a couple of examples. Okay? One is going to be what we call a case 1 problem, where the thing is fired horizontally. So our example is a ball is thrown horizontally with a speed of 12 off a 20-meter high building. So I'd like to draw a sketch. So I have this ball. It's shot this way with an initial velocity of 12, because that's how it started. And it's a 20-meter high building. All right, and I want to know some things like how far over here is it going to land and how long will it take to get there. All right, so the way to do these problems is split them into x and y and try to figure out what information we have. So this V0 of 12, that's an x thing. V0 is 12 meters per second. This 20 meters, that's a displacement in the y direction. I'm going to make it negative because it ends up 20 below where it started. I always know the accelerations. The acceleration in the x direction is 0 because nothing's pulling horizontally. The acceleration in the y direction is negative 10 meters per second squared for gravity. Now, whenever we use the equations, we have to know 3 variables. So the third one in this case is a little bit subtle. See this V0 of 12? It's all in the x direction. Its x component is 12, and its y component would be 0. Now I have 3 things in the y direction. I'm going to use that to find time. So we can use this equation. All right, so then the V0 part goes away because V0 is 0. And I plug in and I get minus 20 equals 1/2 times minus 10 times t squared. This becomes 5. So minus 20 is minus 5 t squared. If I divide by the minus 5, I get 4 is t squared. So t is 2 seconds. So now I know that the time is going to be 2 seconds. So from that, I can maybe find the y velocity. So v over here, v0 plus t, and then v equals 0 plus minus 10 times 2. And that's going to give me a velocity of minus 20 meters per second in the y direction. What does that mean? That means right here, okay, it's going to have the y component of its velocity is going to be downward at 20 meters per second. Okay, and that makes sense. It's going down into the ground. Now, how can I find, say, this distance here in the x direction? Well, the one variable is going to be the same in x and y as the time. So once I know over here that the time is 2 seconds, now I know that the time here is 2 seconds. I can just plug that in. Now I can say use my delta x equation. X equals V0 is 12, t was 2. And then, since the acceleration is 0 here, I can ignore this part because this part's going to become 0. Delta x is 24 meters. I want you to see what happens with the velocity too, right? If I plug into this equation for the x direction, watch what happens. The acceleration is 0 in the x direction, so the velocity is going to be 12. In the x direction, okay, if v equals 0, I'm sorry, acceleration equals 0, that means the velocity is constant. Okay, one more example. Alright, projectile fired at an angle, and here's an example of that. A soccer ball is kicked with a speed of 20 and an angle of 15 degrees. So I have my soccer ball kicked with a speed, that's the initial velocity of 20, and an angle of 15 degrees. And gravity's going to make it come back down and land here. Alright, so this velocity is neither an x thing or a y thing, so I have to split it into x and y. So if I'm going to resketch this here, I have that this is 20, 15 degrees, and we did this before. We found the x component and the y component of vectors by drawing in that little triangle. Now, this is over pressure. This is the opposite side of that 15-degree angle. This is the adjacent side, and I'm going to use sine for both sides to solve. For the adjacent side, I'm going to use cosine, because cosine is adjacent over hypotenuse. So, V0x is going to equal 20 cosine 15 and that's going to give me a value of 19.3. And then V0y is going to be 20 sine 50. That's going to give me a value of 5.2. Now, I can make up my X and Y chart. And I now know that the V0 for the X was 19.3. And for the Y, the V0 was 5.2. We always know the accelerations. Gravity is working in the Y direction. And the acceleration in the X direction is 0. Now again, I need one more variable. I'd like to use this one right up here at the top. Okay, at the very top, I can't say that the velocity is 0 because it's still moving sideways, but it's moving straight sideways this way. Okay, so the Y component of it is 0. So I can say V equals 0 here at the top. And from what we just talked about up there, the X is constant, so the X component of the velocity there would still be 19.3. Now on the side, I can use that to find time. So V is V0 plus AT. 0 is 5.2 plus negative 10 times T. Now if I solve that, I'll get T is 0.52 seconds. All right. Now I might try something like finding its height at its highest point, the height at the top. So I can say delta x is v0t plus 1/2 at squared. Delta x equals v0 is 5.2. 5.2 plus 1/2 minus 10.52 squared. And that's going to give me a value of 1.35 meters. And that's the height at the top. Now, I want to also find this distance here. Okay? And the trick to that is that if it's at 0.52 seconds to get to the top, T is going to equal 2 times 0.52 for the whole trip. Because if there's no air friction, this is symmetrical and it takes the same amount of time to go up as it does to go down. So the time is going to be 1.04 seconds for the whole trip. I can plug that in here. And then I can use that to find the delta x. And then delta x, the x direction is going to be 0 with 19.3. The time we're going to use is 1.4. And then this part, again, becomes 0 because the acceleration is 0. And I end up with delta x of 20 meters.